Okay, let's get into the motion and start this webinar. So the topic that we're going to discuss here is manual handling of configuration changes. And really the subtitle of this webinar is why would you do that to yourself? And as we're going to see, manual handling of configuration changes is something that you don't just, go for lightly headed. That's a very complex topic with some really serious pitfalls. So you need to be really aware of how you do that, why you do that, and what can go wrong when you decide to embark on this journey. So that's the topic of today's webinar. To set the stage for our discussion today, I would like to just describe what configuration changes are. So configuration changes in Android is an externally initiated change in some attribute that might affect the visual appearance of your application. And it might affect not just the visual appearance, but mostly we are concerned about the presentation part of your app. So something happens inside your Android device, and the application that you're executing with that device can change its visual appearance. And if it doesn't do that, then it's not very good. In most cases, configuration changes are initiated in response to user action. And that's really important because there are some lifecycle events that can be initiated like process death when the application is in the background. And then the performance of saving the state and killing the process of your app is not really important because the user doesn't see your application at that time. But configuration changes are mostly happening when the user wants them to happen. And therefore, if your application happens to be in the foreground at that time, then better to be prepared to handle these configuration changes gracefully and hopefully quickly. And then our goal as developers when configuration changes occur is to make sure that they do not affect our application negatively, and we will see in this webinar several examples of what can go wrong. And then we also want to preserve hopefully optimal user experience when configuration changes do occur. So let's just jump right into it, and I want to show you what happens when configuration changes occur. And to do that, I will use this application. It's the application that I wrote for my Android Lifecycles course. We're going to discuss this course a little bit later in this webinar. For now, I just want to use it as kind of a demonstration. And here, when the application launches, we have several activities really, and I want to go into config change activity. So whenever this activity is started, we see that main activity, that's the activity that was shown before, is paused. And then config change activity is created, started, and of course config change fragment, which is shown right here inside this activity. This gray part is a nested fragment inside an activity. It's also created, and then its view created, and etc, etc, etc. So basically it goes through this entire life cycle until the time when this config change activity becomes the top resumed activity in the stack, and then the main activity, the one that was shown before, is stopped. So what happens when we perform configuration changes? And really there are multiple ways to simulate config changes, but the simplest one is to rotate the device. If the application is not locked into portrait or landscape mode, the simplest way to simulate config change is to just rotate the device. And we see that now our application is shown in the landscape mode. And from the point of view of the life cycle, what happened here is that we see that this config change activity, which was the topmost activity, is first ceased to be the topmost resumed activity and then pauses. And the fragment is paused, and then they both go through stop and then destroy. So config change activity is destroyed, and then the fragment is destroyed. And then the same activity, config change activity, the same type of activity is created. But please note that I have this identity and then some number. So this identity just prints the identity of the object that's being created. So here you can see that I use just identity, and I use this API, system identity hash code, to get the identity of this config change activity. And the same goes for config change fragment. So config change fragment, the same goes right here. Where are you? Here, system identity hash code. And we can see clearly that, when this config change activity is destroyed, its identity ends with 666, diabolic number a little bit. And then when it's recreated, a different instance of config change activity is created. And this shouldn't surprise anyone if you've been an Android developer for any period of time, that whenever config change happens, activities and fragments are destroyed and then recreated. And the same applies to fragment as well, right? So we have this config change fragment. The destroyed instance had this number, and the newly created one has a different number. So these are different activity and different fragment that are shown on the screen. And here I have some really simple functionality to just mirror the contents of this fragment into this config change activity. And when I rotate the device, everything is preserved. Okay, so that's the basics of configuration changes. Whenever configuration changes occur, foreground activity, foreground fragments will be destroyed and then recreated from scratch, but we have a means to preserve the state that is shown on the screen. All right, let's jump back into our presentation. What we saw just now is not just any handling of configuration changes, but really a default configuration change flow. So the default goes like that. First of all, config change occurs, and as we said already, this is usually some externally initiated event by the user. Let's say a rotation, locale change, maybe a transition to a dark theme, which is also a config change. And then whenever this happens, Android lets your foreground activities and fragments a chance to save their state. And that's something that we're not going to cover in this webinar because it would take a little bit more time than I intend for you to spend here. But generally speaking, this means that we can, for example, use onSaved instance state callback method to save any state that we want to preserve over configuration changes. And then foreground activities and fragments are destroyed after they save their state. And then Android operating system recreates these activities and fragments and provides a new configuration parameters to them when they are recreated. And of course, then they get the chance to restore the state that was saved before. And of course, if you use view models are exempt from this flow. They restore their state automatically, preserve their state automatically. So that's the default configuration change flow. But the default is not the only way to handle configuration changes. First of all, let's understand something. Let's ask this question, like, when config change occurs, Android destroys all foreground activities and fragments and then recreates them from scratch. Is this the most performant way to do that? Basically to nuke all our user interface, all our presentation layer logic, and recreate them from scratch. For example, activities are kind of heavyweight objects. And the answer is, of course, no, it's not. But it is the simplest way to handle config changes. And in some sense, you can think about this approach to nuke everything and recreate from scratch as something that is analogous to installing new drivers on your computer, right? When you install a new driver, theoretically, your computer can, for example, just apply the new driver and shouldn't require a restart. But still, in many cases, when there are updates to your system drivers or some very important pieces of software inside your computer, it will require a restart. Why that? Because there are two hard problems in computer science. One is naming and another one is cache invalidation. So when we restart everything, when we nuke everything, we basically ensure that we start from a clean state, and therefore we don't need to deal with cache invalidation bugs. So Android nukes all your activities and fragments, recreates them from scratch, and this is the simplest way to handle configuration changes. Now let's just see what can go wrong with config changes. And now we're going to go into the same configuration change activity, right? And let's say I will input some data once again and perform config change now. Boom, our application crashed. And if we go and want to see what's going on, we basically get this latent property listener has not been initialized. And that's the same as getting a null pointer exception in Java. That's the same thing. And if we click here, we see that I have defined this latent listener inside my config change fragment, which I set after I instantiate this fragment. I set this listener from config change activity, and it works, right? It works if I don't rotate my device. I can send the application to the background, bring it back to the foreground. Everything is fine, but the moment I perform configuration changes, my application crashes. And of course, most of you will know why the application crashed, because, well, you can't do that. You can't set listeners on fragments like that. You can't pass listeners into constructors either, unless you use some very clever hacks involving fragment factory. That's not the way to do that. And basically what happens here is that on the first time this activity is created, this code is run because saved in sustain is null. So I set the listener and everything works. But when I rotate the device, this code is not executed anymore. The fragment is restored automatically by Android operating system. But this line of code is not run anymore. And therefore, even though I do have a config change fragment, I don't have a listener variable initialized in it. And that's why we get this thing, this crash. It will be really simple to fix this crash, right? So here, instead of just setting this listener this way and basically capturing it as a state, I can do something like the following. I can go here, right? And I can say the following. My listener, what's going on? Listener. I can't write listener. Sorry, I'm a little bit nervous here. So my listener will be require activity as listener. And here, of course, I assume that the enclosing activity, config change activity, implements this listener interface. And in this case, the assumption is valid. And therefore, if I rerun the application now, hopefully, we will not see this crash anymore. So go to config change activity, input some data, rotate the device, and we don't get a crash. The data is retained. So really simple fix. All I did here is instead of setting this listener side activity and thus making a reference to the enclosing activity, a field, a state inside config change fragment, I just grab a reference to that activity at runtime and cast it into a listener interface and use it. And since I'm pretty sure that this activity implements this listener interface, this approach works. Of course, design-wise, I've just created a coupling between this fragment and the enclosing activity. So the fragment kind of assumes that the enclosing activity will implement this listener, and that's of course coupling. So not always the greatest and the best approach to design your application, but in this case it's actually all right. I just wanted to show you how we resolve this configuration change bug. All right, let's go back to our presentation. And this solution involved basically the solution that I show you involved changing the code, changing kind of the dependencies, the inversion of control, right? Before that, the activity was in control, and now the fragment grabs the activity and casts it. So now the fragment is in control. And we have really simpler solution. And this solution is to use config changes attribute inside Android manifest. And some of you, those at least who might have already been burned by this solution in the past, might scream now next to your screens, no, that's not a simpler solution, that's really bad solution. But unfortunately, really many resources out there online point to these solutions. So for example, this Stack Overflow question, app crash when I change the device orientation, right? And this guy gives a great answer and then says, the best solution is to just add this. For your activity, withhold these fragments in your manifest file. And this question is relatively old, but for example, if I go to Google's Bard, you know, this AI that they released just maybe 2 weeks ago, and I ask the same question, my Android app crashes and config changes, how can I fix that? The first approach that Bard suggests is to use these config changes. So if you think that no one out there uses config changes and and that people don't know about that, well, they do. And unfortunately, it's a very common mistake to think that, you know, if you have problems and crashes over configuration changes, then just set this config changes attribute and you are done. Your application works. And they are not incorrect. So let's just go back here, and I would like to just clear the state, go back to my crash and config change activity. So relaunch the app, go to config change activity, configuration changes, and let's just make sure that the app crashes again. Yep, here's the crash. Now, what we suggested to do is to go into Android manifest file, and here in the place where we defined our config change activity, add the following attribute. So this manifest attribute is called config changes, and we can set it to multiple different values. And in this case, I set it to orientation, screen layout, and screen size. And then I relaunch the app, go to config change activity, input some data here, input the data into fragment, and we see that it's reflected inside the enclosing activity. And then I perform the orientation change, and everything just magically works. Like, I haven't had to change any code, nothing. Just add this config change to my activity inside manifest, and everything works. And of course, that's the reason why so many people recommend using this approach, because it looks like magic. You just throw this line of code into your manifest, everything works, no need to handle configuration changes anymore, you are great. And of course, since we have this webinar, you probably realize that I'm going to tell you that it's not that simple. Before we kind of jump into the complications of this approach, let's just understand what this config changes attribute does. So we discussed this default flow when Android destroys your activities and fragments and then recreates them from scratch. This config changes basically says, do not do that. Don't destroy my activities. Don't destroy anything inside my activities. I will handle that myself. And the different values of this attribute that you can use, let me show you them. Here are the different values. Basically correspond to different configuration changes, the different reasons for configuration changes that can occur inside the application. And so, for example, if you specify orientation, screen layout, and screen size, like I did, that will be something related to the screen and the UI. But you can also specify, for example, locale, right? So that will be a language change. And if I specify just these three, but locally configuration changes happens, then it will be handled in a default manner. So this setting really allows you to specify which configuration changes specifically you want to handle inside a specific activity yourself. And then, as we said, if you specify this setting, then whenever config changes occur, you will be handling them manually. And what happens then is that the standard lifecycle methods of your activities and fragments won't be called anymore. Instead, what happens is that this new onConfiguration_changed method will be called whenever a config change occurs that corresponds to something that you wanted to handle manually. And what's important to realize here is that using this setting config changes, it doesn't disable configuration changes, and it doesn't magically resolve configuration changes for you, but rather what it does is putting all the responsibility and all the burden of handling config changes on you. And the reason why so many developers kind of recommend this approach is because in simple cases, in the most trivial cases, this can work. You can just, tell the system, I will handle config changes manually. And if you don't have anything complex inside your application, any state that becomes inconsistent over this manual handling of config changes, then everything will indeed work magically, just like we saw right now. We resolve this crash by using this setting, even though the underlying code is very problematic. You shouldn't write your Android code like that, right? But it's not a simple solution for configuration changes, really. It's a setting that allows you to handle them manually, but there's no magic there. In some cases, it will work, and your config change, just by setting that, you kind of resolve all your config changes bugs. But in other cases, you might actually introduce much trickier bugs. And now I would like to show you bugs related to manual handling of configuration changes. The bug that I want to show you is on this screen. So we have this config change activity, and we have manual config change activity, which is already defined as handling these config changes by itself. And if I enable this animation, let me just enlarge the screen a little bit, we'll see a very simple animation of a dot moving left to right, bound to the width of this button. And if I perform configuration change, then seemingly everything is fine. Okay, we don't see any immediate problem with what's going on the screen right now. But there is a problem. And the way to demonstrate this problem really is to enable this animation now on this screen and then rotate the device back to the portrait orientation. Sorry, this one is the working version. Of course, what I wanted to show you is the broken one. So let's check out this bug in manual config change activity and rebuild the application. So go to manual config change activity. Again, I enable this animation, rotate the device. There is no evident bug on the screen right now. I enable this animation in landscape and rotate the device back to the portrait. And now we see something is off because the amplitude of movement of this dot is really small. And in this case, you might say, well, that's not a very big bug. That's not like a major bug. Nothing crashed in your app. But it might happen that the amplitude of movement of this animation is actually very important for users. And this bug just demonstrates a whole set of other bugs that can happen. So don't take this as a, it's a small bug, nothing to worry about. It's just a demonstration. And if we go to manual config change fragment, because that's the fragment, the gray area is the fragment, you will see here that I just have this set animation enabled method, and that's probably the most complex way to animate a dot moving left to right on the screen. But I intentionally wanted to animate it this way. And now you need to find the bug. You need to understand the source code of this bug and to fix it. And that won't be easy. Okay, first of all, this bug is relatively subtle, right? Like I rotate the device, I still see this dot animating, I still see this dot animating, and it's not immediately clear that there is even a bug here, but there is. And then when you see this wall of code, it's not really immediately clear what's the problem and what needs to be fixed. And that's the general theme of these bugs. If you handle your config changes manually and your application is not trivial, so you have like not 50 lines of code inside your fragments and activities, but maybe like 500 or 1000 lines of code, then these bugs will be tricky to spot and relatively tricky to fix. So let's understand what's going on here. I know what's the problem because I designed this demonstration. So the problem here is the following. Whenever the animation starts, I invoke this create animation constraints method. And this method uses this get horizontal margin method, which uses display metrics to calculate the margin of movement of this dot. And of course, when we calculate this margin in portrait and then rotate to landscape, then we would like this margin to be different, because as you see in the code, where is that? This margin is just some ratio 0.2 multiplied by the width of my screen. But of course, the width in the portrait and landscape rotation will be different. So I would like to recalculate this margin. But since I'm handling the config change manually here, there is no recalculation. Neither of these methods are called, because if we go and see what's going on, I enable this animation, right? And then I rotate the device. So rotate like that. Neither of the standard lifecycle methods is called, and the only lifecycle method that's being called is this onConfigChanges. And that's, again, because I handle this manually. And that's the source of this bug. So how could we fix this bug? Well, I know what the fix is. Actually, hopefully I still have it in my... Yep. That's the fix for this bug. And as you see, it's relatively tricky. I'm grabbing the idea of this view, and then I clear some constraints, and then I connect other constraints. And I do that in this onConfigChange method in order to make sure that whenever config change occurs, the constraints associated with this animation also change. And now if I enable this animation, rotate the device, okay, it's still not clear that there is no bug, but I enable animation again, rotate the device back to portrait, and now the amplitude of my animation remains constant, remains the same like before. And this means that this code indeed fixed this bug. But please notice two things. First of all, the bug was relatively tricky to spot. Second, the bug was relatively tricky to fix, all this black magic. And furthermore, there is another bug here. If you notice, when I rotate the device, there's this animation, right? You see this white screen and then some translation. And that's another aspect of that. Since I'm handling config changes manually, there is additional animation, additional side effect, basically, that I did not intend to have, but I do have it. And then now I need to understand why I have it and how do I fix that. And all of that are the results, direct results of handling config changes manually here inside my config change activity, setting this setting inside Android manifest. And for comparison, let's remove this setting for a second. Remove this setting, remove this piece of code, and let's understand like what's going on, what's going to happen if I wouldn't handle config changes manually inside this activity. The application restarted, go to manual config change activity, enable the animation, rotate the device, and just the animation is disabled, and the button again becomes enable animation. I can click on it, the animation is enabled, I rotate the device. So immediately we see that it's so much simpler to spot the bug. The bug is just clear, it jumps on us. And that's the general theme with manual handling of config changes. If you have a bug, if it doesn't crash, if your app doesn't crash, oftentimes this bug will be relatively subtle, and it can be a really corner case that 5% of your users will ever encounter, and then you have a really hard time reproducing this bug when users give you 1-star reviews in Google Play. So without this manual handling of config changes, it's easier to spot the bug, but it's also easier to fix it, okay? And the fix here could be the following. We have this isAnimation enabled flag, right, which I set somewhere here, right, inside this set animation enabled, and we can do the following. We can override onSaved instance state and just go out state, put what will be that boolean, right, and the key will be anim, and the value will be isAnimation enabled. And then inside on create, here I always recommend, you get this saved instance state inside on create view as well, but I always recommend restoring your state inside on create, and this will keep it consistent between your activities and your fragments. So consistency in a big code base is a very important topic. So I always recommend restoring the state inside on create, even inside fragments. So isAnimation enabled will be just this saved instance state, and of course I need to do, well, let's just do saved instance state, get boolean, and the key is anim, and then of course the default value we don't need it, but since this can be null, we want to set it to false initially. Okay, so we set this isAnimation enabled, and then inside on create view, instead of setting the animation enabled to false, we want to set it to isAnimation enabled. And hopefully this fixes the bug. Let's reinstall the apps. Go to manual config change activity, enable the animation, rotate the device, and boom, everything still works. And please notice that even if I enable the animation in landscape mode, I go to portrait, and the amplitude of this animation is correct because everything is recreated from scratch. So all this code that recalculates the margins for the animation is rerun, and therefore there is no bug. So two things: much simpler to spot these bugs when you kind of don't handle config changes manually, and also much simpler to fix them, because all I had to do is to save this isAnimation enabled flag over configuration changes, and that's it. That took care of that. Instead of doing all this hackery with, kind of changing just part of my configuration in response to on config change callback. As you've just seen, and hopefully I convinced you that it might look very simple to handle configuration changes manually and magically resolves you of all the responsibility to handle config changes yourself. But in practice, this approach can lead to very tricky bugs. And these bugs are much harder to spot to begin with, and then much harder to fix reliably. And in many cases, you will fix this bug and introduce another bug. So cache invalidation. The problem here, of course, is that some state is preserved, but the external configuration changed. And so now you need to manually invalidate part of your state and update it according to the changes of the external configuration. And this is that state cache invalidation problem, classical problem in software engineering, one of the two hard problems to solve. So once you embark on this journey, you are dealing with cache invalidation. And I'm not saying that there is no use case for this approach, manual handling of configuration changes. Of course, the biggest benefit of this approach is that neither activity nor fragments are destroyed. And therefore, first of all, you get performance boost. So activities and fragments are kind of heavyweight objects, and therefore destroying and creating them from scratch, it can be costly. But not always you need this performance boost. And we're going to discuss kind of the guidelines, kind of a mindset that you need to have when deciding whether you need to handle configuration changes manually or not. But before that, so let me just quickly go over this course, my new Android Lifecycle course. This course covers everything that Android developers need to know about Android Lifecycle. So Lifecycles, for example, is the most common set of questions during Android interviews. And when thinking about the content of this course, I thought, like, if I would interview a senior Android developer, what would I expect them to know? Regardless of what position I interview them for, because there are kind of niche, exotic stuff like the lifecycle of content provider and how you can auto-initialize libraries. But that's not what all Android developers need to know. That's kind of a niche stuff. But what would all senior Android developers need to know? And I put everything that I think is relevant there into this course. So my goal with this course is to bring any Android developer to the position where they know enough about Android lifecycles to pass an Android interview with me, at least in the context of Android lifecycles. And I'm really pretty tough interviewer. If that's something that you think you would like to take, you would like to improve, especially if you're going to job hunt anytime soon, or you know other developers, maybe you work with your colleagues, then you can find this course here on this URL. And as with all my courses, I think it's a fair game to go to your employer, and if they have a budget for education, trainings, and development of their staff, it's a fair game to ask them to pay for it, because it's a professional content. It's not some, like, I want to learn some new stuff that maybe not we are going to use, maybe or maybe not it will benefit us. This course covers the most fundamental, the most important aspects of Android development, so it's a fair game. And if you do decide to enroll in this course, or you recommend it to someone who does decide to enroll, then you can use this coupon code when you enroll, Manual Lifecycle, and this will give you 25% off as a discount. It's valid for the next 2 days, so if you know anyone or yourself, and just make up your mind quickly and use this coupon code. I do really think that all Android developers need to know about that, the contents that I cover in this course. And unfortunately, I've met enough developers with even 10 years of experience who wouldn't understand, like, when you use on resume as opposed to on pause inside activities and fragments. So this course covers all these bases for Android developers. So what are the considerations that you need to take into account when deciding whether you want to handle configuration changes manually or not? First of all, please realize that 80% of the time your users spend inside your app will be spent on 20% of the screens of your application. That's so-called Pareto principle, right? Like, it's called also 80-20 rules. So most of the time your user spends will be spent on a kind of smaller portion of the screens. But if you have a relatively big application, let's say with 100 screens or even more, then these 20%, they're also subject to Pareto principle. So basically, like, say 20% of your screens are 20 screens. So of those 20, 80% of the time, users will spend on the 20 of the 20, which means, like, let's say 5 screens. And what it means is that if you have even big app, let's say 100 screens inside your app, then your users will probably spend most of their time on just 3 or 4 screens. And if that's the case, then these screens are probably the candidates for this performance optimization, for this optimization. The other screens where your users spend, let's say, 0.1% of their time on that screen, maybe it's not worth investing any of your time and risking having all these tricky bugs there. So that's like the first mindset. But then in addition to that, even if you have identified these 2-3 screens, you should ask, like, how often do my users actually experience configuration changes? Because, again, many Android developers overestimate the rate of occurrence of these events. Yes, in some cases they can be quite common. Let's say if you design a video player, then it's very reasonable that your users will just, they will find the video in a portrait mode, but when they actually want to watch the video, they will rotate their device to landscape mode. Very common use case. So there are special set of apps, special sets of features where you can expect a lot of configuration changes. But for many apps, that's not the case. And some apps are even locked to portrait mode, so they don't support rotation or rotation change. And then the configuration changes that they experience are related to, let's say, dark theme to light theme transition, which happens very rarely, or multi-window, when you have multiple applications on one screen, which most Android users aren't even aware of this feature. Even Android developers like myself don't always know how to enter this multi-app layout. So be honest with yourself. Like, are your users actually experiencing configuration changes, or you are about to embark on preliminary performance optimization? And then, even if you do know that your users experience configuration changes at a decent rate, the next question to ask is, if you perform this manual handling of config changes and you go into the trouble and you take on all these risks, what will be the benefit for you, for the users? Is it worth it? Is it worth the time that you're going to spend? Is it worth it, the risk that you're going to introduce? And really, in most cases, the answer to these questions is no. Okay, so most applications, they don't need that. Say that, most big applications, with many users, they do employ this approach, especially on the main screen. So, either that will be YouTube or Gmail or whatever. The main screen, if you support at least orientation change, which is the most common configuration change in Android, then you'd probably want to optimize that, because once you've got to millions or tens of millions of hundreds of millions of users, even slight optimization of their experience is probably worth the hassle for you, because you can put 2-3 developers working on this performance optimization because your company probably has these resources. So be honest with yourself, understand the benefits, understand what you're going to invest into this performance optimization, and if you do need it, then now you know how to do that. And last thing that I would like to mention here is that there are some nuances. Okay, nuances to manual handling of config changes. First nuance is that this approach is incompatible with the single activity architecture. So that's the recommended architecture by Google. But if you have a single activity and you set it to handle configuration changes manually, a specific set of config changes manually, then basically your entire application will handle config changes manually. And then you need to remember and you need to take care of that in your entire app. And I'm sure that there are projects out there that do that. I can't recommend this approach. It's just a recipe for bugs for no good reason. And therefore, most probably, if you want to embark on this journey, you will need to extract at least one additional activity, and then that activity will handle config changes manually. So this kind of breaks this single activity architecture. If you use view models, so view models, they retain their state over configuration changes automatically, and that's their big selling point. But if you handle config changes manually, then, well, everything retains their state. You can use any kind of MVP or just, have all your logic inside activity, have this God activity mess, and everything will be retained because nothing is destroyed. So view model becomes completely obsolete if you embark on this optimization journey. And still, even though view model becomes obsolete, and I personally don't like view models, I think they complicate stuff, I still say that if you use view models in other parts of your app, then use them for consistency on these parts on these screens where you handle config changes manually. It won't break anything, okay? So handling config changes manually doesn't mean that your view models will stop working. They will work, they will just become kind of obsolete, but for consistency, keep using them. And what I find to be one of the biggest problems with handling manual config changes manually is that if you don't handle them manually, if the activity and fragment are destroyed and recreated on config changes, then in most cases, if you test your app for process death, then it also covers the config changes. So process death is when your process is destroyed by the Android operating system when the app is in the background, and you use on-saved instance state, on-restore instance state, and inside view models you use saved state handle to preserve your state. And it's a little bit more, actually a lot more complicated if you want to preserve global state or singletons. But generally speaking, that's what process death is. And if your app supports process death, if you test for process death, you can be reasonably confident that it also supports configuration changes because these flows are similar and some of the approaches overlap. But if you decide to handle configuration changes manually, then all bets are off. For those parts of the application where you handle config changes manually, you will need to develop two standalone testing plans, one for config changes and one for the process death. So that's an additional QA effort. And if you decide still, after all we've discussed, you decide that it's worth for your project to perform this performance optimization, please make that everyone on your team understand that there's this part of your project, of your app, that handles config changes manually. They need to be aware of that because, generally speaking, when I go and I work on some screen, let's say fragment activity or whatever it is, I assume that it goes through the standard lifecycle. So if you handle config changes manually, I'll need to kind of be aware of that. And that's not something I assume out of the box. So if you decide to do that, just make sure that all the team, that you are all on the same page, everyone understands that, this part of the application needs special care, special attention if we go and modify it in any way. And with that, Thank you everyone for joining. I remind you that I have this new life cycles course, and if you want to learn life cycles at the level that is I would require from a senior Android developer during an interview, or you have teammates that you think will benefit from that, then I will be really glad to be your instructor. And with that, thank you for joining. See you in the next webinar then. Bye everybody.